Welcome back to Zito TechVerse. In this video, we're covering the top 30 JavaScript and React interview questions. We'll go through core concepts and advanced topics, complete with code examples, diagrams, and real-world analogies. Let's get started. Here is our roadmap. We begin with JavaScript core concepts, move into advanced JavaScript, then cover React fundamentals, and finally finish with React hooks and advanced patterns. We have 30 questions to get through. Let's kick off section 1, which focuses on JavaScript core, var versus let versus const. What's the real difference? Let's start with the absolute basics that still trip people up. Var is function scoped and hoisted as undefined, which causes surprising bugs. Let is block scoped and lives in the temporal dead zone until declared, so you can't use it early. Const is also block scoped, but can't be reassigned. The key trap. A const object is still mutable, only the binding is locked. You can change its properties, you just can't point it at something new. Think of name tags. Var is a sticky note. You move anywhere, let stays in its room, and const is engraved. You can't swap the tag, but you can still edit what's behind it. What is a closure, and why is it useful? Closures are one of the most loved interview topics. A closure is a function that remembers the variables from the scope where it was defined, even after that outer function has returned. This keeps the outer scope alive, which is exactly how you create private state, function factories, and memoization. It's also the mechanism that makes React hooks like useState work. Picture a backpack. When a function leaves its home scope, it carries a backpack of the variables it grew up with, and it can still reach inside long after it left. How does the this keyword work in JavaScript? The this keyword confuses everyone at first. The golden rule. This is determined by how a function is called, not where it's written. In a regular function, this is the object that called it, or undefined in strict mode. Arrow functions are special. They have no ownness, so they inherit it from the enclosing scope, which is why they're great for callbacks. And you can force this explicitly with call, apply, or bind. Think of this like the word I in a sentence. Its meaning depends on who's speaking, not on where the sentence was written. Explain hoisting in JavaScript. Hoisting means JavaScript moves declarations to the top of their scope before executing code. Function declarations are fully hoisted, so you can call them before they appear in the file. Var is hoisted but initialized as undefined, which leads to subtle bugs. Let and const are hoisted too, but they sit in the temporal dead zone and throw if you touch them early. Function expressions and arrows are not hoisted as callable. Imagine a guest list to read out before the party. The names are known up front, but the actual guests only arrive when their line runs. How does the JavaScript event loop work? The event loop is the heart of asynchronous JavaScript, and a favorite senior question. JavaScript is single-threaded, with a call stack and queues. When you call something async like a timer or fetch, the browser's web APIs handle it, and later push a callback onto a queue. The crucial detail is priority. Microtasks, like resolved promises, always run before macrotasks like set timeout. So the loop empties the stack, drains all microtasks, runs one macrotask, and repeats. That's why the classic snippet prints 1, 4, 3, 2. Think of a single chef with a to-do list. Urgent promise notes get done before regular timer orders. What is prototypal inheritance? Prototypal inheritance is how JavaScript shares behavior. Instead of classes copying methods into every instance, objects link to other objects through the prototype chain. When you access a property, the engine walks up that chain via the proto-link until it finds it or hits null. The class keyword is just syntactic sugar over this mechanism. The benefit is memory efficiency. One shared method, many instances. It's like inheriting family recipes. You don't get your own copy of every recipe. You look it up in the shared family cookbook your parents passed down. Equals equals versus equals equals equals. Which should you use and why? A quick but important one. The double equals operator compares after type coercion, which produces surprising results. 0 equals an empty string is actually true. Triple equals compares both value and type, with no coercion, so it's predictable. Always prefer triple equals to avoid subtle bugs. The one acceptable use of double equals is checking against null, since null double equals undefined is a handy shortcut for either nullish. Think of double equals as judging two things close enough after a makeover, while triple equals checks, they're genuinely identical, no disguises. Explain debounce versus throttle. Debounce and throttle both tame high-frequency events, but differently. Debounce waits until the events stop for a moment, then fires once. Perfect for a search box, so you only query after the user stops typing. Throttle guarantees the function runs at most once per interval, regardless of how many events fire, ideal for scroll or resize handlers. Both are essential for performance. The analogy. Debounce is an elevator door, waiting until people stop entering before it closes. Throttle is a turnstile letting one person through every few seconds, no matter how big the crowd. We are now moving on to section 2, where we dive into advanced JavaScript. Callbacks versus promises versus asyncs. async/await. Asynchronous code has evolved a lot. Callbacks were the original approach. Pass a function to run later, but nesting them creates the dreaded callback hell. Promises improve this with objects representing a future value that you chain with, then and catch. Then async/await arrived as syntactic sugar over promises, letting asynchronous code read like synchronous code, with familiar try/catch for errors. That's the modern standard. The analogy: callbacks are leaving your number for a callback. A promise is an order ticket you can track, and async/await is simply reading that ticket as if the food were already in front of you. What does promise.all/race/all_settled do? The promise combinators let you coordinate parallel work. Promise.all waits for all promises, but rejects immediately if anyone fails. Great when you need everything. Promise.all_settled also waits for all but never short circuits, giving you each result or error, ideal when partial failure is acceptable. Promise.race settles with whichever finishes first, success or failure. Promise.any returns the first success and ignores failures until they all fail. Think of it this way: all is a group photo where you wait for everyone. Race is a sprint where first across the line wins, and all settled is a roll call where everyone reports in. Map versus for each versus filter versus reduce. These four array methods come up constantly. For each simply iterates and returns nothing, so it's for side effects. Map transforms each element and returns a brand new array of the same length. Filter returns a new, usually shorter array, with only the elements that pass a test. Reduce is the powerful one. It folds the whole array into a single value, whether that's a sum, an object, or anything else. Picture a street of houses. Map repaints every house a new color. Filter keeps only the houses you like, and reduce adds up everyone's electricity bill into one total. Shallow copy versus deep copy. How do you do each? Copying objects correctly trips up many developers. A shallow copy duplicates only the top level. Nested objects are still shared references, so mutating them affects both copies. The spread operator and object.assign are both shallow. A deep copy clones everything, including nested structures, giving you full independence. The modern built-in for this is structured clone. Picture a folder. A shallow copy photocopies the cover but shares the same papers inside, so editing one edits both. A deep copy photocopies every single page, so the two folders are genuinely separate. What are ES6 destructuring and the spread/rest operators? ES6 gave us syntax that makes JavaScript far cleaner. Destructuring pulls values out of arrays or objects straight into variables, with defaults if you like. The spread operator expands an iterable into individual elements or props, and is the backbone of immutable updates in React. The rest operator looks identical but does the opposite. It collects remaining items into a single array or object. Imagine a delivery box. Destructuring unpacks only the items you need. Spread tips the whole box out, and rest sweeps the leftovers into one pile. Explain event delegation and event bubbling. Event delegation is a performance pattern built on event bubbling. When an event fires on an element, it bubbles up through all its ancestors. Delegation exploits this. Instead of attaching a listener to every child, you attach one listener on a common parent, and use event.target to identify which child actually triggered it. This is especially valuable for dynamic lists where items are added and removed, since you avoid wiring up and tearing down listeners. It's like a classroom. Rather than giving every student their own teacher, one teacher watches the whole class and responds to whichever student raises a hand. Now we step into Section 3, React Fundamentals. Let's look at how React core concepts work. What is the virtual DOM, and how does React use it? The virtual DOM is React's secret to fast UI updates. It's a lightweight, in-memory copy of the real DOM, made of plain JavaScript objects. When state changes, React builds a fresh virtual tree and compares it against the previous one, a process called diffing. Then it applies only the actual differences to the real DOM, which is the slow, expensive part. This minimizes direct DOM manipulation and keeps your app snappy. Think of editing a document draft. Instead of reprinting the entire book for one typo, you compare drafts and reprint only the pages that actually changed. Props versus state. What's the difference? Props versus state is fundamental to thinking in React. Props are passed into a component from its parent and are read only. The component can't change them. State is internal, mutable data that the component owns and manages itself. Changing either one triggers a re-render, but the ownership differs, and data always flows one way, from parent down to child, through props. The analogy: props are ingredients handed to a chef by the customer, fixed and given. State is the chef's own cooking progress, which they fully control and change as they go. What is JSX, and how is it different from HTML? JSX is the syntax that makes React feel natural. It's a JavaScript extension that looks like HTML, but it isn't HTML. It compiles down to React.create element calls, which are plain JavaScript. Because it's JavaScript, there are differences. You write class name instead of class. Events are camel case like onClick. You embed expressions with curly braces, and you must return a single root element. Think of JSX as a blueprint that looks like the finished house, while a compiler quietly turns it into the actual construction instructions behind the scenes. Why do React lists need a key prop? Keys are how React tracks list items efficiently, and a common interview topic. A key gives each item a stable identity across renders, so React's diffing algorithm can match old and new items correctly when the list changes. The critical rule: use a unique, stable id, not the array index. Using the index causes subtle bugs, lost input state, wrong reordering, and unnecessary re-renders whenever the list is sorted or items are inserted. Keys are like seat numbers at a theater. Even if people shuffle around, the usher knows exactly who belongs where. Without numbers, you get chaos and mix-ups. Controlled versus uncontrolled components? Form handling in React comes in two styles. In a controlled component, the input's value lives in React state, making state the single source of truth. Every keystroke flows through React, which makes validation and conditional logic easy. In an uncontrolled component, the DOM itself holds the value, and you read it on demand with a ref. Controlled is predictable and React-driven. Uncontrolled is simpler for quick inputs that don't need validation. Think of controlled as a GPS, where the app always knows your exact location, and uncontrolled as a paper map in the glove box. You only check it when you actually need it. What is conditional rendering in React? Conditional rendering lets your UI react to state and props. You have a few tools: the ternary operator for either or, the logical and short circuit for render only if, and early returns for cleaner component bodies. One classic gotcha: if you write count and some element and count is 0, React actually renders the 0 on screen, so coerce it to a Boolean first. For complex branches, store the element in a variable to keep things readable. It's like a smart billboard showing open or closed depending on the time. Same screen, different content based on conditions. We've arrived at section 4, React hooks and advanced patterns. How does useState work, and what are its pitfalls? useState is the most used hook, and its pitfalls show up in every interview. It returns a value and a setter, and calling the setter schedules a re-render. The key subtleties: state updates are asynchronous and batched, so reading the variable right after setting it gives you the old value. When new state depends on old state, like in a loop or rapid clicks, use the functional form that receives the previous value. And never mutate state directly. Always create a new value or array. It's like ordering a fresh plate instead of scribbling on the old one. React only notices the change when you hand it a brand new reference. Explain useEffect and its dependency array. useEffect handles side effects, anything outside pure rendering, like data fetching, subscriptions, or timers. It runs after the render commits. The dependency array controls when. An empty array runs it once on mount, while listing dependencies reruns it whenever those values change. Crucially, you can return a cleanup function to tear down subscriptions or timers before the next run, or on unmount. The common bugs are missing dependencies, giving you stale data, or wrong ones, causing infinite loops. Think of setting up and packing away a market stall. The effect sets it up when you arrive, and the cleanup packs it away before you leave. No mess left behind. Use memo versus use callback. When to use each. Use memo and use callback are both about memoization, but for different things. Use memo caches a computed value between renders, so an expensive calculation only reruns when its dependencies change. Use callback caches a function reference, which matters because a new function every render can cause memoized child components to re-render needlessly. Use them to avoid costly recalculations and unnecessary renders, but don't over-apply them, because memoization itself has a cost. The analogy: use memo saves the answer to a hard math problem so you don't redo it, while use callback keeps the same phone number so your friends, the child components, don't think you moved. What are the rules of hooks, and why do they exist? The rules of hooks exist because of how React tracks them internally. Rule 1. Only call hooks at the top level. Never inside loops, conditions, or nested functions. Rule 2. Only call them from React components or custom hooks. The reason is that React identifies each hook purely by its call order, not by name. If you call hooks conditionally, the order changes between renders, and React mismatches which state belongs to which hook, corrupting everything. Picture a numbered checklist read in the same order every time. Skip a line one day and every following item shifts, throwing the whole list out of sync. What problem does the Context API solve? The Context API solves prop drilling, the pain of threading a prop through many intermediate components that don't even use it. Context lets you provide global-ish data like the current theme, the logged-in user, or locale, and any descendant can read it directly with use context no matter how deep. A provider supplies the value, and consumers subscribe to it. One caution: Overusing context causes broad re-renders, and it's not a replacement for a full state manager like Redux. Imagine passing a message person to person down a long line versus a building-wide intercom where anyone can tune in directly. That's context. How do you optimize performance in a React app? React performance optimization is a senior favorite. Start with React.memo to skip re-rendering components whose props haven't changed. Pair it with use memo and use callback to keep values and callback stable, so memoization actually works. For large apps, code-split with React.lazy and suspense so users only download what they need, and virtualize long lists to render just the visible rows. Finally, use correct keys and avoid creating inline objects or functions in hot render paths. Think of a smart kitchen. Don't recook dishes that haven't changed. Prep ingredients once, and only bring out the menu sections customers actually open. Use state versus use reducer. When to choose use reducer? Use state and use reducer both manage state, but they fit different complexities. Use state shines for simple, independent pieces of state. Use reducer is better when you have complex state, with many related transitions, because it centralizes all the update logic in a single pure reducer function. You dispatch actions describing what happened, and the reducer decides the next state. This is predictable, easy to test, and mirrors the Redux pattern. Think of use state as a light switch, perfect for one bulb, and use reducer as a control panel, better when many switches interact and you want all the wiring in one organized place. What is Redux and the one-way data flow? Redux gives you predictable global state in a single immutable store, which shines in large apps with lots of shared state. The data flow is strictly one way. You dispatch an action describing what happened. A pure reducer computes the new state, the store updates, and the UI re-renders. State is read-only. The only way to change it is through reducers, which makes the whole system traceable and debuggable. Modern Redux uses Redux Toolkit to cut the old boilerplate dramatically. Picture a bank ledger. You can't secretly edit balances. You submit a transaction, the clerk records it, and everyone reads the same trusted, updated ledger. What are custom hooks and why create them? Custom hooks are how you share stateful logic in React. A custom hook is simply a function whose name starts with use, and that calls other hooks inside. It lets you extract logic, like data fetching, local storage syncing, or debouncing out of components, and reuse it everywhere. The result is cleaner components and logic you can test in isolation. Common examples are use fetch, use local storage, and use debounce. Think of a custom hook as a reusable power tool. Instead of rebuilding the same wiring inside every component, you build it once and plug it in wherever you need it. What are error boundaries in React? Error boundaries keep a single broken component from crashing your entire React app. An error boundary is a component that catches JavaScript errors thrown during rendering anywhere in its child tree and displays a fallback UI instead of an empty, broken screen. You implement them with class components using getDerivedState to switch to the fallback and component didCatch to log the error. One limitation: they don't catch errors in async code, event handlers, or server-side rendering. Think of circuit breakers in a house. If one room shorts out, the breaker isolates it so the whole house doesn't go dark, and users see a friendly message instead of a blank page. And that's our top 30. Thanks for watching Zito TechVerse. That wraps up our top 30 JavaScript and React interview questions. If this video helped your preparation, please like and subscribe to Zito TechVerse. Drop your toughest questions in the comments, and I'll see you in the next one.